Hello, for today's worked example, we are working with this crank rocker mechanism. So the way this works is point A is fixed, point C is fixed, and point B is attached to the edge of this, this crank, which is going to be moving back and around in a circle. So as this moves around in a circle, it can slide in a slot on AB, which is going to mean AB is going to basically rock back and forth to account for the rotation. So this is a way to get intermittent motion out of a continuous rotation mechanically, at least. All right, so currently theta, so the angle of CB is at 60 degrees. Theta dot is constantly rotating at -2 radians per second, so it's clockwise 2 radians per second. I want to know what is the current angle of phi, the angle of AB, and what is the rate at which phi is changing? So phi dot, the angle, this piece here. So that's what I want to know. I'm going to need to do some geometry for the first part. And then for the velocity, I'm going to need to do some relative motion analysis. All right, so let's deal with the geometry first. Let's see if we can figure out the angle phi. So to figure that out, I'm going to need to know kind of the exact location of point B. So assuming this is 0, I'm going to try to figure out what my location of point B is. All right, so it's actually not that bad. So I know that the radius of this orange wheel is 0.5 meters. So if I go, if I were to go from here and here, it'd be 0.5, 0.5. All right, so that's all well and good. From there, I can use my 60 degrees and another 0.5 for the length. So the x position of point B with respect to the origin at point A is going to be equal to 0.5 to get over here plus 0.5 cosine 60. All right, that's going to be 0.75 meters. And the y location at point B is going to be to go up, it's 0.5, 1 radius, plus 0.5 times the sine of 60. So 0.5 plus 0.5 sine of 60. And that is going to be equal to 0.933 meters. All right, so based on that, I can kind of figure out the overall triangle. So I can draw on a big right triangle now. So I've got this leg here is 0.75. This vertical leg is 0.933. The inverse tangent so tan -1 of opposite 0.933 over adjacent 0.75 gives me the angle phi, which is going to be 51.21 degrees. So that's the first part of the problem. I figured out angle phi. While I'm here, I'm also going to figure out the distance. So what is the current length between A and B? And that would simply be equal to A squared plus B squared equals C squared. So 0.933 squared plus 0.75 squared. And that distance is 1.197 meters. So it's a little over a meter from point A to point B. All right, so current phi, current D. I'm going to go to the next slide and we're going to figure this out. So here is our diagram. And remember this, we're going to draw out just kind of the legs and the UR and U theta directions based on this. All right, so we can either start from point A because it's fixed, or we can start at point C because it's also fixed. The way I set this up is I went from point A to point B to point C. So A is connected to B, B is connected to C. So let's draw point A kind of goes up like this to point B, which goes back down to point C. So I've got like that, and then that. So A is down here. D is the current length. It is going to change though. So A and B aren't a constant length apart. B is up here. C is down here. So the R1 direction would be going from A out to B, like so. So UR1. And then 90 degrees off of that would be U theta 1. Going from B to C, UR2, and then 90 degrees counterclockwise. I'm going to go out this way. Is going to be U theta 2, like so. All right, so what I know about this is BC was at a 60-degree angle. So this should be also at a 60-degree angle from horizontal. And then that means if this is 90 degrees off, this is at a 30-degree angle. It's not accurate in my drawing, but those should be 60 and 30-degree angles. Whereas up here, this R1 direction, that was the angle I figured out with phi. So phi was currently 21 or 51.21 degrees. And over here, this is going to be 90 minus that number. This is going to be 38.79 degrees. All right, so this, believe it or not, is going to help. I'm also going to draw in the last, so this length here is 0.5 meters. That's the constant length between B and C. All right, so the velocity of point C with respect to A is going to be equal to the velocity of point B with respect to A plus the velocity of point C with respect to B. This is the same starting equation I use for most things. Velocity of C with respect to A, so that's actually going to be equal to 0 because point C doesn't move. It's only point B that's kind of rotating around. So 0 is going to be equal to, and in this case, I've got AB is both rotating and extending. So I've got multiple pieces to that. And then BC, it's not extending, 0.5 is constant, but it is rotating. So I've got a piece of that as well. So if it is rotating and extending, the velocity equation, I'm going to have R dot 1 in the UR1 direction plus R1 theta 1 dot in the U theta 1 direction plus for the second part, C with respect to B, it's going to be plus R2 theta dot 2 in the U theta 2 direction. So I don't have an R dot 2 because this is a constant length. All right, so if I were to build this out, what I would have is, all right, 0 is equal to R dot 1. So I'm calling this D, so it's D dot. In the UR1 direction, the UR1 direction is 51.21 degrees up. And then plus R1. So R1 is currently, the current length of that was 1.197 meters times this angle of AB, I call it theta dot 1, but really it's phi dot. And then it is in the U theta 1 direction. So I'm going to say cosine 38.79 degrees, but it's really in the negative x direction. So I'm going to make this a or sorry, I'm not gonna, I shouldn't be putting this in yet. I should be putting in the direction, which is the u theta 1 direction, which is 38.79 degrees, like so. Plus R2, that is simply 0.5 times theta dot 2. So this was rotating at a rate of -2 radians per second, so 0.5 times -2. And the theta 2 direction is going down kind of at a 30-degree angle. All right, so that is my base equation. I'm going to break that into x and y pieces and see if I can solve for, in particular, phi dot. All right, so let's take this. C. All right, there we go. All right, so let's take out the x pieces of this. So in the x direction, overall velocity must be equal to 0. So it's d dot cosine 51.21 degrees. Here I've got the negative sign, so it's a negative x direction. So minus 1.197 cosine of 38.79 degrees times phi dot plus, so 0.5 times 2 is going to be just -1. So minus 1 cosine 30. One cosine 30. That's just a known value. In the y direction, it's also 0 velocity in the y direction, so it's going to be d dot times the sine of 51.21. Here it is positive y direction, so plus 1.197 times the sine of 38.79 times phi dot. So it's -1, also negative y direction, so double negative makes a positive, plus 1 times the sine of 30. All right, so here I've got 2 equations and 2 unknowns. So I'm not going to go through the full math of this, but this is a solvable set of equations. Basically, what I'm going to want to do is take one of the equations in the full PDF solution. What I did is I took the x equation, solved it for d dot. Once I figured out d dot is something times phi dot, I plugged that into the y equation, solve for phi dot. So if you do that, you're going to get a phi dot value of -0.826 radians per second. And you can also, if you're interested, solve for d dot. And that would, I did not solve for that one, so let's skip that. So this is the number we are looking for. So this is the rate of rotation of arm section AB. All right, so it is rotating at -0.28 or 0.826 radians per second, which means that phi is getting smaller, which the way we've measured it, if this is rotating clockwise, you'd expect B to be going down, and so phi to be getting smaller. That makes sense. All right, so that's all we have for this example. Thank you for watching, and I hope to see you again.